Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2025. Question number 2 is on the topic of forces. The stopping distance of a car is affected by the condition of the brakes and tires. A car is being driven around a corner when the driver sees some roadworks. A car is being driven around a corner when the driver sees some roadworks, okay? The driver applies the brakes when the car is 24 meters away from the roadworks. So that the distance is S. S is not for speed here. When they say use the physics equation sheet, we're using the SUVAT equations. So S is for distance. The velocity of the car changes from 18 meters per second to 0 meters per second. So initial velocity is U, which is 18. Final velocity is V, which is 0. Calculate the constant deceleration, which is A, needed to stop the car in a distance of 24 meters. The equation that you need to use is V squared minus U squared equals 2AS. V is 0 minus 18 squared equals 2 multiplied by A times 24. So let's do that. 2 times 24 is 48 A, and 18 squared is 324. The negative value still carries, so A is equal to minus 324 divided by 48. So that should give you minus 6.75. So the deceleration has to be minus 6.75. Now the negative value sign needs to be there. The marking scheme doesn't specify that you need the negative value, but it does include in the answer. So it's better to put because it is asking about deceleration. As a safety measure, the speed limit on the road was reduced. Explain how the safety of road users is affected by the condition of the brakes and tires, reduced speed. You should refer to the think-in distance and brake-in distance. Now they have actually given you 4 different hints. You need to explain how the safety of the road users is affected, right? By the condition of the brakes and tires, the reduced speed, right? And you should refer to the think-in distance and the brake-in distance. Now let's discuss what these things actually mean. Now, what is this think-in distance, right? That's a distance covered by the car while the user is actually thinking about applying the brakes, right? So what actually affects the think-in distance, right? That's to do with the reaction time of the driver. So if I say think-in distance as TD, brake-in distance as BD, right? So let's talk about the think-in distance, right? How does the condition of the brakes and tires affect the think-in distance? Let's talk about that first. So the first point, right? The condition of the brakes and tires does not affect the think-in distance, right? What about the speed, right? speed does not affect affect the thinking distance or the reaction time. However, if you reduce the speed, you would reduce the thinking distance because the car is not going. Actually, I should have said thinking distance. Let me remove that word thinking. It's not the thinking distance, it does affect it. So, does not affect the thinking or reaction time. Reaction time. I shouldn't have tried to combine 2 points here. I made a mistake. So, speed does not affect the thinking or the reaction time, right? But reduced speed will decrease the thinking distance. Right? What about the braking distance? Hold up a bit. The braking distance. Right? Now the braking distance is affected by the brakes and the tires. Right? Poor or worn out brakes or tires increases the braking distance. Right? Reason, since there will be less friction between tires and the road or brake pads. Right? 3. What about the speed? Reduced speed will decrease the braking distance. Now, let's combine both of this. We've talked about the thinking distance and the braking distance, how it affects or how they are affected by the brakes and tires and the reduced speed. In terms of safety, right? How will this affect the user's safety? Since stopping distance equals thinking distance plus braking distance, poor brakes and tires increases the stopping distance. Right? Now, reduced speed will reduce the stopping distance, right? And reduced speed also reduces the chance of a driver losing control sorry, what's that? Of the car and the chance of collision. Right? So reduced speed will also reduce the chance of the driver losing control of the car and the chance of a collision, right? So this decreases the risk of injury during a collision and increases or improves the safety of the driver and the passengers. Two identical cars are driven along a straight level road. One car has a greater speed than the other. The driver of each car applied the brakes until the car stopped. Both cars traveled the same distance while braking. Explain how braking at a greater speed affected the risk of the brakes overheating. Now, this question links to the transfer of energy. It's actually linking to the first topic on energy, right? So, to stop a car with greater speed, a bigger frictional force or braking force is needed. Why? Since it would have a bigger kinetic energy, right? Now, because it has bigger kinetic energy, you need a bigger energy to stop this, right? And we describe this as work being done. So, a bigger work needs to be done to stop a faster car, right? What does that mean? So the risk of the brakes overheating is greater for a faster car. That brings us to the end of question number 2. Thanks for watching. I will link, if you want to watch question number 3, I will link question number 3 to the end of the video, or I will link all the videos as a playlist. Thank you.